it was with little fanfare earlier this year that I introduced addition of ordinates. Let's go through a recap of it. If f of x is equal to this cubic function here, it could be said that the f of x can be made by doing g of x plus h of x, where g of x is this particular function, x cubed, and h of x is this function. We're just sticking them together. And actually, if I really wanted to, I can sketch the graph of f of x by noting that g of x looks like this, and h of x looks like this. And what I could do is use addition of ordinates, that is, add together the y values of the individual functions and produce the resulting graph. Now that's pretty tricky. Even for this function here, it's a little bit tricky. And those of you thinking, why don't you just sketch f of x? Absolutely. F of x equals x squared x plus 2. And if I was sketching that, I would say we've got a point there, -2, and that's what we're going to get. So if I added the ordinates together, the y values, what I would get is this graph here. But it's much easier to do that using the techniques that we know so far, which is sketching a cubic function. Now, how does this relate to what we're doing at the moment? Well, we can make a combined trig function by adding 2, 3, 4, 10 trig functions together. Okay, so here's sine x and cosine x being added together to form a function f of x. Okay, and it actually can be quite tricky or difficult to see what the resulting graph will look like. Like, we don't know what that one is, whereas when I add these two functions together, by recognition, I know, yep, cubic function, bang, I know how to sketch those. Whereas we don't actually know how to sketch sine x plus cosine x. So what we do is we sketch each one individually and then just bang together the y values or add the ordinates together, and we get a result. And what I'm going to do first of all is show you kind of some of the weird and wonderful graphs that can be created. So f of x is equal to, let's say, a times sine b times x. So that's our orange graph there, and I can vary those values now. G of x, let's make another function. Let's just say that that's c times, let's go cosine graph, d times x. So what I can do is play around with the amplitude and the period of these individual graphs. And what I'm going to do is get a resulting graph, which is h of x is equal to f of x plus g of x. We can subtract the ordinates as well, okay, but we're doing addition of ordinates here, so we're just going to add them together. All right, and this grey graph here is the result of adding the two of them together, okay? So what I'll do is just click off with those two graphs. So the grey graph will be the result of the addition of the two, okay? I'm going to pull them back up again. And what I'm going to do now is vary some of the values here, the amplitudes and the periods. Now have a look at this grey graph. Okay, that's the one that I want you to concentrate on and see what cool things happen as I start to vary it. All right, so not much so far with that grey graph there. In fact, yeah, there we go. So slight variations, but cool things happen when I start to change the period. All right, so notice that what happens here is it goes up and sort of bends down lower, goes up higher, bends down lower, okay? Now I'm going to start to vary the period here and amplitude here. Not much is happening. Now I'm going to get rid of the bottom two graphs, just play with grey by itself, okay? Let's just see what I can create here. Wow, now we're talking. Okay, so you can see here what you can get by changing the period and the amplitude is all sorts of crazy looking graphs. Now, I don't know what on earth that would model, but there's some variations there on what can happen. Okay, so by adding the ordinates together, and this is the resulting function here, this graph here to the right is -4 sine 1/3 x take away 0 points, blah, blah, blah. That's what that is, okay? And those of you who by recognition go, oh yeah, I know what that's going to look like, it's going to look like this. Well, hey, credit to you, but I've got no idea what that would look like other than imagining the original function g of x and imagining the yellow function, which is f of x, drawing them individually and then starting to add the ordinates together. All right, it's a really difficult process, okay? And when, I say when you find this process difficult, you're not alone, and it's certainly something that I have a bit of trouble with. Right, so here's some for your notes here. So this pink function is the one that we're concentrating on. That's the combination of the two functions. And notice that we get some different variations. So they're not all the same thing. They don't cycle the same way through one period, okay? Same over here. So what we get is kind of like an inflection. So it looks like it's going to turn back down, but then it jumps back up again. So let's try it. Okay, so here's my advice. Take your time. Get the key points and shape around the key points to understand the graph's behavior. If you're going to have any success at it, it must be done on graph paper. And here's the only example that we'll do. There's only a few examples from the book. All right, so what we're going to do is add the blue to the red and work out what's going to happen. All right, it's a fairly easy start. Okay, so we're going to do 0 and 3, which will equal 3. All right, now what we're going to do now is compare what happens initially. So this one here, what it's going to do is sort of start to fall, whereas you notice that this one here increases quite quickly. And so what it's going to do for a time is it's going to increase faster than this falls, okay? And it's actually going to, the graph is going to creep up, okay? So because this is increasing faster than it's falling, it offsets the fall and starts to add. But notice here that it increases and it almost looks linear, whereas this is like a real spill. So it starts to fall faster than it climbs. So it's going to go up, I anticipate, and then sort of start to come down again. Okay. Now, where's it going to come down to? Well, see this intersection point, I can get an idea of what that would be on the resulting graph of f of x plus g of x by looking at 2 and a bit boxes. So I go 1, 2, 2 and a bit boxes means that those y values there will double whatever the intersection point is. So here's the behavior so far. It's going to increase for a time, and then it's going to fall faster than it climbs, so it's going to start to drop. It's going to drop down through that point there, okay? All right, now, by the way, you've got to do this in pencil first of all. You'll never get this right first go. Well, I shouldn't say never, but I never get it right the first go. All right, so at some point here, what's going to happen is this increases and this decreases, and the increase and decrease will offset each other, i.e. they'll be exactly the same. And I can see what's going to happen at around about here. We know we've got 1, 2, 3, 3.5 boxes roughly. 1, 2, 3, 3 and a bit. So at roughly this point here, both of them are the same distance away from the x-axis, which means that they cancel each other out, or we're going to get an x-intercept. All right, now the trick is to look for symmetry, right? So what we're going to note here is that this point here will be exactly the same on this over here, okay? Because we can see down and up is exactly the same. We can see that the graphs are exactly the same on either side around this point here. All right, so what's going to happen is it goes up, it goes down, it's going to go through that point there, and it's going to continue to go down. Now, how do I know that? Well, what I'm going to do is look at this max and this max here. Now, that's -3 and that's 2, and -3 plus 2 is -1. All right, so it's going to dip down to there, hit that point, and go back up again. And again, it's going to be symmetrical. So that intersection point there is going to match up with this point here. It's going to climb up to there. And what's going to happen in reverse now is this thing over here. So we're going to end up there. But what's going to happen here is that this increases, or as this decreases, it's going to decrease faster than it increases. So we're going to get another maximum over here. All right, so that's the first phase, if you understand what I'm saying there. That's what's going to happen there. That's the first phase. So I can kind of go over that a bit thicker now. Whoops. To there. All right, now what I can see after pi to 2 pi, I get like another phase of this that's completely different. Okay, so notice that this is like over and sort of like a cup. Okay, and this one now is reverse. This is the cup and a cup. Okay, so the behavior on this part here is going to be different. All right, now what's going to happen? All right, well, again, what I'm looking for is an x-intercept, and the way what I'm looking for is when the values of y offset each other. Oops. So that's when it happens there. So you notice here that that's 1, 2, 2 and a bit, 1, 2, 2 and a bit. So somewhere around about here, we're going to get an x-intercept. So essentially what's going to happen now is that the function is going to go down and hit this x-intercept. All right, now to find out how low does it go. So as it goes down, what we're going to note here is this is -2 and this is -3. And if I add -2 to -3, I'm going to get -5, i.e. it's going to be way down there. So what's going to happen is as I add these negative values together, it's going to go down to here. And because I can see it's symmetrical on this side, what I'm going to do is grab that point there and put it in the equivalent spot, which is there, and it's going to come up to the equivalent spot, which is there. To there. Right, so we can continue to do this in a solid line now. Okay, and then what I foresee happening now is that this pattern will just continue. It'll be this cycle followed by this cycle followed by this cycle. Let's just see what GeoGebra says. Okay, so our first graph is f of x equals 2 times sine of x. So there's that one, and the other one was 3 cos 2x. Okay, and h of x equals f of x plus g of x. Okay, so let's just see whether we got that right. So we're looking for the pink or yeah, whatever color that is. Okay, so yeah, we definitely got that right. So we can see the behavior from 0 through to roughly 3 or pi, because pi is 3.14. So we can see here at the x-intercept, the y-intercept rather, it sort of comes up, then goes down to -1, goes down to -1, then comes up and gets to this point here. And then it's going to fall lower, return to the same point, and basically just continue in this pattern indefinitely. So we can see here that we get this repeating pattern now from here in. Okay. All right, so there is the only example I'll do. Okay, and the exercise is 6H1ACD. So it's 3 problems, only 3 problems. Now you might think that will take about 5 minutes, but you're kidding yourself. Okay, when you make mistakes on this and when you get these wrong, I understand. Okay, it's a very difficult process, and to be completely honest with you, I've practiced this question previous to recording or prior to recording this video. So I also kind of knew how this one was going to work out. So I'm just giving you a little bit of a reveal there that I've kind of, in inverted commas, cheated a bit on this, and you're not going to get that same opportunity. Now, this is also as hard as it gets. I can show you addition of ordinates problems from exams, and they're going to be nowhere near as difficult as this. So if you can get an idea of how this works with trig functions, I promise you this, you will be able to do it on whatever exam question you get. Okay, but it's very important to practice these, and like I said, to get any success with it, you need to use graph paper so you can count the number of boxes or squares. Good luck with it, girls, and ask for some help, but also put your favorite graphing program up on the screen and have a look at what you're anticipating as well. That's going to be a really good thing to do, is to have that up on the screen so you can see what the target actually is going to be or what you should have got.